Good afternoon, everyone. I'm Natalie Piperidis, and it is my privilege to welcome you to the SRA webinar series. I am very happy that so many of you are joining us today. And I'm confident that today's session will be offer invaluable insight to the latest advancement in sugarcane breeding research, and that our must-attend event will offer important perspective on the intriguing landscape of breeding. So first of all, I would like to begin by acknowledging the Aboriginal and Torres Strait Islander people of this nation. We acknowledge the traditional custodian of the lands on which SRA is located and where we conduct our business. We pay our respect to ancestors and elders, past and present. Today's webinar will commence by a presentation of approximately 40 minutes, followed by a Q&A session. During this presentation, we kindly request that all participants keep their microphone muted to ensure clear audio. Questions will be entertained during the Q&A session scheduled at the conclusion of the presentation. So, without further delay, I would like to introduce our speaker, Dr. Jason Eglinton. Not that he really needs an introduction anyway. So when I asked Jason to give a webinar, he actually said yes straight away without hesitation, but then challenged me to actually find some time in his calendar. So I have to say it was a big challenge, but and it was not an easy task. But as I'm a very determined person, obviously I did it, and here we are. Jason is the general manager for the variety development team. Jason has over 20 years experience in applied R&D, variety development and commercialization. He was previously professor of plant breeding at the University of Adelaide, leading the development and marketing of malting and feed barley varieties. Jason joined SRA in 2017 and has become responsible for SRA plant breeding, from validation of new traits and technology through the development and delivery of new commercial varieties. So for me as a geneticist, comparing the genetic leap from barley to sugarcane was like, bungee jumping, a very scary challenge for me and for most, I reckon. With barley boosting a mere like 14 chromosome compared to sugarcane staggering 120, the contrast is stark. Yet, for Jason, it has been a seamless stroll through the park. He's approached this task with unparalleled skill, executing his mission flawlessly and with steady precision, and without skipping a beat. So without further delay, Jason, I'm giving you the virtual floor.
Thank you, Natalie. That's a very generous introduction. Thank you very much. And Natalie, thank you for the webinar title. So there was certainly a lot of enjoyment in working so closely allied to the brewing industry, but there's some good fringe benefits working in the sugarcane industry as well. I want to begin by acknowledging the team. So SRA's plant breeding team, 56 people, really diverse group from people looking after field operations through to fairly high-end laboratory-based roles, and obviously lots and lots of genetics and dirty work boot plant breeding. The slides and the story I'm going to tell this afternoon really belongs to these people. For most of the time I've been sitting in my office or in meetings or in phone calls, so I'm really grateful and appreciative of all the hard work that goes into the breeding efforts by this team of people and by the broader group of people, both within SRA and within productivity services, within milling groups and our collaborative growers that all make a contribution. So I guess with the title of this talk, some of my staff might be groaning that I'm going to spend half an hour talking about barley and only a little bit on sugarcane. So I've restrained myself to just one slide on the barley industry. So this is the national yield over time for the barley crop. And like most commodities, you can see the occasional seismic effects of annual weather conditions. But the important takeaway from this slide is the year-on-year increase in productivity. So it's tracking at about 2.5% per annum over that 50-odd year period. And that's not all plant breeding, of course. It's pretty hard to partition it, but most estimates put it at about 50% of the ongoing gains being due to on-farm management improvements and about 50% to genetic improvements. And I guess over that journey, one of the notable and probably largest contributors to yield improvement in terms of farm management practices has been around the planting window. So over that time, things like minimum till, no till, direct drill, faster planting, wider planting rigs, earlier target seeding dates has meant the whole crop has moved in terms of its average date of planting, and there's no late planted crop to speak of. That's a bit of a contrast to sugarcane. And I guess the other contrast is in the barley world and perhaps the grains industry more generally, it's really easy to see the yield advance when new varieties are launched, particularly the key new varieties. So the rate of gain is of a significant magnitude. There are some other things that are pretty common. So there's too many varieties released, more than any grower or anyone particularly wants. And in any given production area, there'll be 3 key varieties that represent 70% of production. So again, pretty similar to what we see in sugarcane. Now, if I put up the same slide for the Australian sugarcane industry, we do not see that same trend over time. And I guess we're all very conscious of this. We're all very conscious that there are a lot of forces at work trying to push this yield and productivity down. So, there's a long history of pest and disease incursions that try to push this down. There's considerable land use competition from tree crops and horticulture. There's really significant urban sprawl, and some of those things are actually taking, not just challenging the area, but actually taking some of the more productive area. So there's some contrasts and similarities, and they do have a bit of context on the general operating environment for plant breeding in the two industries. So I'm going to move to just some quick overview of SRA's plant breeding program to give some context to changes and progress and where we're at today. So it spans about 2,000 kilometres of our east coast. On this map, we have the SRA sites marked in red. The colour-coded area is a 1-hour drive time by road around those centres, and the black dots are FAT, Final Assessment Trial, or RVT trial sites in those respective regions. So a large spread, that large group of people that I put up on the acknowledgements slide, spread across that area. The super simplified version of how the breeding program works obviously begins with crossing. Early generation selection is abbreviated to PAT, progeny assessment trials, where individuals are assessed within their families in the first instance across plant and return crop. The second stage is the first time that they are assessed as individual clones, so abbreviated to CAT trials. Around 10,000 individual clones assessed, again across plant first return, and in most cases requiring a propagation phase to go into that series. The final assessment trials, which are predominantly off-station trials, so the early generation work done on our SRA farms. By here, we're down to 500 to 800 clones, generally simplified as one step like that, but before variety release, a candidate clone will go through a second series of final assessment trials, and then with some parallel time in approved seed propagation with productivity services organisations, we end up with an average of around 12 years from that first planting of the progeny assessment trials through to commercial release. Now, the program's structured with a carefully crafted mix of centralisation and regionalisation. So crossing, probably most of you realise, is centralised at Moringa. That progeny assessment trial phase is conducted at Moringa, Brandon and Mackay, and the selections from that move on to trials again in those three locations before fanning out to the broader selection trial network. Wilmar also run a plant breeding program, and they use some SRA derived crosses and some of their own crosses, run their own early generation selection scheme, and the germplasm meets up again in the final assessment trials in the Burdekin. So we're now 4 years ago when we looked at a review and reorganisation of I guess our internal structure, and we moved to consolidate the disease screening activities across Tully and Woodford, which sat under one particular executive manager, with the farm operations side of things, which sat under a different executive manager, and the plant breeding into one business unit. And that certainly simplified a lot of the decision making and created I think a more cohesive team. And out of that, both the restructure and a number of other changes made at the same time, we were able to save $1 million from the annual operating expenditure of the program in 22-23, and the team has been able to manage that new baseline for the current financial year. So obviously SRA is a levy funded organisation, and that levy has been fixed since the inception of the company, and like everybody else, costs go up, so savings are part of the picture. So if I go back again to look at some context in terms of when I started with the breeding program, one of the concerns at that time was how new varieties were travelling in the market. So this slide shows the market share of new varieties, and some of you will be aware the year I started on there was the incursion of smut, and there was a lot of variety changeover at that period of time, and new varieties were representing sort of 20, 25, 30% of the commercial production. If we roll back before 2006, they were pretty similar levels, and go back further in history, there were ebbs and flows, but not really prolonged periods sitting down below that 10%. So 10%, if new varieties are less than 10% of the commercial production, there's a serious question about what contribution can the breeding program really make if varieties are not being adopted. And one of the interesting things at that time and in the lead up to that was the BSES approach to assessing genetic gain. So I hope Jo Stringer sees this and likes the subtitle there. She did some fantastic analysis to generate these, but was never happier than when I joined and said that we should stop doing this. So the thinking was, well, let's calculate genetic gain from commercial production values, and let's compare the commercial production of new varieties with the results from established varieties, and that will be a sensible real-world way to assess the genetic improvements that's made over time. And That's essentially what this figure shows, and it comes out at something like a 1.8% genetic improvement, in this case for tonnes of sugar per hectare, over a pretty long period. Now, I think the industry at the time didn't feel like they were getting 1.8% improvement over time. They probably felt like something considerably less than that. But this was the corporate position, if you like, in terms of what's being achieved. Now, there's absolutely nothing wrong with the maths and statistics that were applied to this. The bulletproof best practice approaches. The problem was the underlying confounding effect in the data. So you can appreciate that maybe the worst growers in a region are not likely to be the first ones to adopt a new variety. So when comparing the productivity of a new variety with established varieties, we're actually comparing different groups of growers, early adopters versus late adopters. The other thing is, of course, you can only access a new variety by buying approved clean seed, whereas you can use dirty, diseased, old on-farm seed to grow an established variety. And we know there's a yield benefit overall from using clean approved seed. So that's another confounding effect. So this long-term data set that BSES and SRA were putting out was actually showing there's a 1.8% yield difference between early adopters, late adopters, clean seed and not clean seed. And in amongst that, some positive or negative genetic effect. So when I started with SRA, we sat down and pulled apart the trial data, established a long-term controls that have been in, or varieties that have been in trials for long enough to give representative baseline benchmark, and assess the genetic gain in the final assessment trials from 2007 through to the 2013 assessment series. And what we found was the average annual genetic gain, or the long-term genetic gain expressed annually, was 0.1%. So the breeding program was barely moving forward at that point. So the task was to sit with the team and work through what we might do differently to accelerate the genetic gain and get a heartbeat and a pulse back into it again. Now, the next few slides are actually things that I haven't looked at for some time. They were slides that I presented in 2017 after we decided and agreed on our plan. So it'd be interesting to see how well they age. But like all breeding programs, SRA's program starts out with a relatively large number of experimental entries, which decreases over time as we progress through the breeding program. And as material gets to more advanced stages, the cost and the precision of the testing increases, the breadth of the testing increases. And I guess that's important context to understand the different levers that we can pull and what the current context of the germplasm actually is. So at that point in time, there was testing for a bunch of deal breaker type traits that was only happening at the very last stage of the breeding program. And that was diminishing the effective population size in those FATs. So by the time we ruled out a bunch of candidates for those traits, for example, that I've listed, we've now taken out a lot of the selection pressure that we should have been applying for productivity traits. So the relatively simple strategy is to try and look at how many of those traits can we start to apply selection pressure for much earlier in the breeding program. So we started to look at, can we use NIR for some of our fibre quality measures? Can we expand our Pachymetra facilities so that we can accommodate some earlier generation material? We started with the inoculation of some of our early propagations to apply smut pressure as well as taking better advantage of opportunistic field infection. So again, to try and get rid of some more of those passengers before they get to the advanced stages of trials. We also looked at the early generation stage in terms of the quality of the material that was going in, and looked at the crossing strategies that support that. And over time had a specific effort on decreasing the sheer number of parents and sheer number of crosses, increasing the population sizes from elite crosses, implementing molecular selection prior to that PAT stage where we could, and establish an ongoing introgression program to diversify the genetic variation going in. We also had a bunch of work around how precise or how accurate our trials and tests were. There was a practice of selective harvest, which diminished some of our ability to have very good spatial corrections in the analysis. We certainly have variation in plot lengths that we've now able to take out routinely with drone-based measures. We look to try and improve the response to selection for CCS by better understanding moisture and maturity relationships in those samples at time of harvest, and some of the spatial variation in early generation trials being accounted for by digital soil mapping. So that was broadly the program of work as it started in 2017, and the sorts of things that we were trying to change. And I guess I'm going to give a bit of a glimpse into how we've gone and what the outcomes of some of that have been. So the introgression program didn't actually have to start from scratch. So we began in 2017, but of course there are a series of individual fixed term research projects over history that have done different things around spontaneum and other wild relative germplasm, both in terms of generating material and characterising some material. So we were able to put all of that existing material together to begin a field trial program straight away, and then follow that up with a deliberate crossing strategy to help us systematically mine those wild relatives. And so far we've seen 2 varieties released for the New South Wales 2-year production system that are actually first back cross from spontaneum. We have a novel smut resistance and a linked molecular marker that is in field validation at the moment. It appears to show very strong resistance in our Woodford trials. So we're now looking at it under some pretty hot field conditions in the Herbert. We've been able to identify a first, I think, nematode resistance, and I'm going to come back to that a little later in the talk. The general overall focus of that germplasm pipeline is to try and focus on improving ratoon crop performance, and so there are a number of strategies with slashing to apply additional ratoon or harvest style pressure on those trials. And we at the moment have what we think might be our first candidates for potential energy cane varieties coming out of the program. So some good results out of what is a relatively small effort. So we've structured this introgression pipeline to be about 10% of the overall breeding effort. Some of the other things that we were interested in doing, like applying DNA-based selection, really meant we had to invent some new things. So at that point, there'd been a lot of genetic analysis work done, but no QTL of really large effect identified, no marker trait associations validated to the extent that they would justify routine-based selection. And so it was a fairly big step forward when the team were able to validate resistance for SMUT and associated molecular markers. Now, the genetic control of SMUT resistance is sufficiently complex and different between different varieties that this marker work really only can be used for quite a small subset of our resistant parents. It's quite effective in those parents, but we really do have more work to do if we're to apply it more broadly across the whole parental mix. One of the other big things that was invented was one of our fast track technologies. So we've used a range of strategies to try and shortcut that 12-year timeline to commercial release. And that bottom left slide is showing us the beginning of tissue culture production from seed. And on the right-hand bottom panel there, we've got a field trial planted from that material. So using that tissue culture step within the breeding program gives us the chance to take 3 years off that production cycle. Now, the very first clones and populations that we tried this approach on now have some of the elite progeny at the sharp end of the breeding program. And I think Tom might have introduced the first few to the Mackay RVC meeting a couple of months ago. So they're pointing towards consideration for commercialisation over the next year or two, or couple of years. So that's been an important new tool in the toolkit. It's not something that can be used at really big scale because it's quite a expensive and high risk strategy, but it's certainly got a role in some of our more specialised breeding streams where we do want to take a more aggressive approach. The drone-based selections come a huge way from our original thinking of just being able to use it to correct for differences in plot lengths or other spatial covariate type analysis. So we've got an example on the screen where CGESH has been able to take a pretty average trial with a heritability of 0.61 and apply those sort of covariates to get it up to a respectable, useful trial in terms of selection with a heritability of 0.8. But the real promise of this technology is the yield estimations. And so we're sitting at a similar accuracy with drone-based prediction of yield with these growth models from drone imagery as we are with our genomic selection models. So we've applied, I guess, a lot of these sort of tactical changes, some technology changes through different phases of the breeding program. Some of these changes take a long time to work through. Some of them begin to work relatively quickly. So I'm going to start to share a bit of an assessment of how the responses to these changes have looked. Firstly, on pachymetra resistance frequency. So we've got this sort of stop-go colouring here to reflect the frequency of resistant in green, intermediate in yellow, red, susceptible in the final assessment trial stage. Now, you'll notice that the years go up to 2022. The trials are named for the year that they're planted. So that 2022 cohort was going through pachymetra screening up to and including last year. So it's up-to-date data, I guess is my point. The frequency of resistance across the SRA germplasm is relatively high. So you can see back from the outset of this series in 2004, it perhaps started to tumble as maybe there was more emphasis placed on smut. But then we can see a fairly positive response to selection over the last few years. That 2022 result is a bit disappointing. It's dropped down, and we know a little bit about why that is. We've struggled a little bit with the consistency of that particular method, and are about to make some major capital investments in the infrastructure to make sure that we are continuing to run those trials at best practice, and continue to put the right selection pressure at the right phase of the breeding program for that important disease. I guess smut is a slightly different story. That when before smut arrived, we had a very, very low frequency of resistance in the germplasm, and offshore screening began in 1997 in preparation for that incursion. And you can see over that journey a pretty good breeding response in terms of it increasing the frequency of resistance in advanced clones. And of course, it takes more and more to increase that level. Now, we do occasionally, I guess, get feedback from our industry, like the Burdekin. Well, we don't have pachymetra, so perhaps we should relax our effort on that. Or the very wet parts of the wet tropics don't need such strong smut resistance, so perhaps we could relax on that. The challenge from a breeding perspective is, though, that for the most part, the majority of the industry would prefer to have a variety that is resistant to both pachymetra and to smut. And if we only have a frequency of resistance of about 50% of each of those, that really means on average, only about 25% of experimental clones in the final assessment trial are going to have both. So our effective population size to push for increased yield and increased CCS is actually only a quarter of what we would hope it to be. So it is really important that we continue to look at early generation selection, pressure crossing strategies, and high precision late evaluation to continue to push up these disease resistance frequencies. So the frequency of traits is one way that we can assess the breeding program. We have a number of measures around genetic gain, which I won't unpack, but I've got a sort of cheap and cheerful one that we do use that I find is easy to communicate. And that's as simple as how many good clones do you have? All right, so this chart is just a simple count of the number of clones in each cohort that have a relative economic genetic value greater than the variety Q208. So for those not familiar, we have a selection index, which is a relatively sophisticated model based on all of the economic drivers of profitability for the sugarcane industry. So it balances out miller and grower returns and incorporates the trade-off between tonnes cane and CCS, penalties for diseases, the differential value of a unit of CCS versus tonnes of cane in terms of harvest cost, and gives us a unified value to look at the economic value of a candidate clone. So simple as how many clones are better than the old standard Q208. And obviously, if you haven't got many that are better than 208, the probability of being able to release a gun variety is not high. And if you've got lots, then you've got a better chance of doing that. And more importantly, from the management of a breeding program point of view, if we're improving over time, the number of clones that are better than an old standard should be getting more and more year by year. The blue part of the line, the blue part of the chart, I should say, the line, is how much better than Q208 are they? Are they just better by a fingernail margin, or are they getting, I nearly said more better then, is the margin improving over time? So I think probably this speaks for itself that you know, the breeding program really is responding, notwithstanding the fact that the way this data works, 21 and 22 series final assessment trials are incomplete. So they're in a different colour because we will get the second return data for the 2021 series this year, and we only have the plant crop data for the 2022 series. So there's more data to come, and we may find more winners or more losers depending on that data. But the trend is going in the direction we want. So we've got the breeding program's lead metrics going in the right direction. With ongoing genetic improvement, we expect to improve our probability of releasing varieties that are more attractive to growers. So let's have a look at variety adoption. And I've used this slide a fair bit over the years, and it's nice to keep adding to it. And we can see back in 2018, the approved, I should backtrack and explain this slide, why the units are in hectares. So approved seed is sold in a range of different formats. So it goes out as billets, as whole sticks, as one-eyed set-derived plantlets, and as tissue culture. So we take all of those values and apply a sort of industry standard planting density and express the values as an area planted. So if we look back at 2018 and the area planted from approved seed, you can see that the blue section of the bar representing new varieties was very, very low. And so telling us that while growers are interested in getting disease-free approved seed, they're not particularly interested in the new varieties and are quite comfortable with the established varieties. So it's been a concerted target obviously for SRA, but also in partnership with our productivity service partners, to not only have the genetic improvement under control, but also focusing on having the right sort of performance information, the right sort of marketing support to really, I guess, underpin the merits of those varieties. And we set a significant record in 2022 sales, and it was great to see that was maintained last year. And I guess the other important thing is it's not just one or two varieties that are leading the charge. We've got quite a suite of varieties that are contributing to that significant change in variety adoption, and they're playing roles across all of the regions. And some of these are very much still in the process of finding their way across all of the regions. So if we come back to where I started with the market share of new varieties, so this is how it was when I started. So presumably I've been able to do something good about this. Well, actually, no, I didn't. It just got worse and worse the longer I stayed here. And last year still below 10%. But these are pretty hard metrics to move. This is the whole commercial crop. But we've got some reason to be optimistic that last 3 years of increase is more than just noise. And we're confident that is actually a trend line back. And we really would like to see this number up in that 15 to 20% of the commercial crop, because that really demonstrates that the breeding program is adding value, and that's what it needs to do. So why can we be a little bit confident? Well, I guess we've just shown you the volumes of approved seed going out, and so we're beginning to see the commercial production from those sales. So my thanks to MSF Sugar for providing this data from the 2023 harvest from 2 of their mill areas. And what I'm presenting, let's just have a look at the left-hand panel in the first instance. So that's the Mulgrave mill, and I'm looking at tonnes of sugar per hectare for 3 of the major varieties for that mill area. And it's split out for plant crop, first return and second return. And we can see there the new variety SRA 26, significantly above those long-term standards. There's only one, we've only included the plant crop data for SRA 28, it's a newer variety. There is some return data available, but it's less than 5,000 tonnes, so we don't consider that to be a good representation. Now, you might be sitting there thinking, hang on, didn't Jason say that in that old genetic gain analysis you shouldn't compare new varieties and old varieties in commercial production because it's confounded? Yes and no in this case. So that plant crop data point for SRA 26 is over 60,000 tonnes of commercial production, both in Mulgrave and also in South Johnston. So it's not a small data point. It's actually bigger than the established varieties. So there's a lot of this out there. And the margin of difference is not 1.8%. It's closer to 10%. And 10% on last year's sugar price is something around $300 to $400 a hectare difference. So you don't need blubs to be able to tell 26 is better than 208. And we've only got the plant and first return data for South Johnson, and notice the shift in scale. South Johnson had a pretty tough set of growing conditions last year, but essentially a similar sort of picture emerging there. We do have a little bit more SRA 28 to be confident in that data. And this is a similar sort of productivity result and economic advantage that we see in the data from Tully Sugar and that we see in the data from Wilmar and the Herbert. So grounds for being optimistic about the contribution that some of these new varieties are going to make and the continued expansion of their market share. If we look a little further along the pipeline to a newer variety where we have a lot of trial data in most regions, SRA 32 has shown a pretty consistent 16 tonnes of cane per hectare advantage over the standard varieties, both in irrigated and rain-fed conditions. The data that I've got on the left here there is from the Burdekin, so under a fully irrigated scenario. And last year we did have the very first commercial production of SRA 32 at any meaningful scale. And of course, this data is 100% confounded by those effects of one very good grower is growing SRA 32 and the rest of the tableland industry is growing everything else. But nonetheless, from that 4,000 tonne sample, we can see a pretty big tonnes cane advantage to SRA 32 in line with what we hope to see from what we expect based on trials, and then also tempered by the fact that that variety was grown on quite deliberately on some lower yield potential situations. So we're quite optimistic about the current raft of varieties and what they're going to contribute and what their adoption profile looks like over the next little while. We're quite comfortable with the underlying genetic gain that's going to drive the next generation of new varieties. I guess the other element of development and growth that we're interested in is our people. And a really important development for SRA has been the success by UQ and Coffee, led by Professor Lee Hickey, the success in getting funding for the ARC Training Centre in predictive breeding for agricultural futures. So the UQ-led centre has got a massive collection of logos here of the industry partners that are participating in that centre. And this will be the training ground for a really important cohort of animal and plant breeders. And SRA is participating in this through 3 significant projects. So 2 PhD projects and an industry fellowship, and there'll be a range of other training opportunities for our staff as well. So the first of the PhD projects that we're about to embark on is going to train Chris Tom, one of our variety officers, in fast-track plant breeding and look at rapid deployment of that novel nematode resistance that I mentioned earlier. So we've already generated the BC1 populations and identified resistant parents. Those are in the photoperiod facilities, and the BC2 families will be produced later this year. And so there'll be an opportunity for this PhD project to absolutely throw the book at this germplasm to look at combining the tissue culture-based fast-track strategy with genomic prediction and then field validation of the resistance to try and see how quickly we can produce a variety with this this novel characteristic. And you can't help but think that if we can have a variety that's resistant to both nematodes, and I should point out this is the original resistance, or the original accession where we found the resistance, it had resistance to both root lesion and root knot nematode. In the work that we've done so far, we've only focused on root lesion nematode. So there's some work to do. We don't expect they're necessarily under the same genetic control and that we capture both with this exercise, but just to clarify that. So a variety with nematode and Pachymetra resistance will be fascinating to look at its return behaviour. The second of the PhD projects is going to look at genomic prediction of cross performance. So lots of people look at estimated breeding values based on combination of the genotype and the phenotypic data. But that's really limited to sort of considering the additive genetic variance. And we know that non-additive variance is a pretty important part of sugarcane genetics. And so this different approach taken in this project will look at actual progeny performance. So progeny over the last 10 years, crosses that have been made and the trials that have been run, and to look at training a genomic prediction model based on actual progeny performance, interrogating all of that data to look at both general combining ability and specific combining ability, and hopefully coming up with some new ways to help the program optimize its crossing planning and subsequent population size decisions relating to that. So a couple of pretty exciting PhD projects that are going to have good plant breeding graduates at the end. The Industry Fellowship Project is, again, a great look forward into what we can do. So I've mentioned the strength of the drone-based yield predictions. I've mentioned also that the genomic selection-based predictions are continuing to strengthen, and we've got some more work to do that we can see ways to further improve that. In a sort of separate vein, the cytogenetics work that Natalie's doing is really shedding a new light on the scale, the magnitude of the variation that we see in the macrogenomic layout of our varieties is probably something that we've underestimated. And so the ability of some of the new techniques to have a faster and more thorough look at chromosome organisation is going to be another piece that we look to bring together to give us better insights into our current germplasm and response to selection, but more importantly, an integration of our predictive breeding tools. So I guess on reflection, I think that the breeding team has done a huge job over the last 7 to 8 years in terms of adopting a range of different tactics, commercial aggression, and new technologies. And we've got an outlook and a program forward to keep building on that. So I think the outlook for both, I guess, the continued development of the activity within the breeding program, but more importantly, the quality of the outputs and impact on industry from it are really quite bright. Now, I've gone a couple of minutes over and probably eaten into question time a little bit. I'm sorry, but happy to take questions.
Thanks, Jason, for your brilliant presentation. So as you say, it's no time for question. If you have any question, you can either type it in the chat box or the Q&A box and raise your hand, and I then unmute your microphone to ask when you are prompted, and then mute your microphone again if you could. So, okay, let me navigate through this. So actually, I've got a question from, I'll just ask the first question because it's on my email. And Anthony Young, he had to leave, so but he will be listening later on for your answer. So congratulations on your new job, Jason. I would like to ask if the full extent of the incidence of RSD was apparent to you when you commenced as a sugarcane breeder. Do you think you would have reconsidered your stance on not pursuing genetic resistance? Given the example of Musman recording of high RSD incidents and going bust, do you think your successor will revisit RSD resistance as an industry-wide way of improving the productivity of the Australian sugar industry and moving the genetic gains up? Thanks, Anthony. That's a pretty long question.
It's got a few statements in there. I'm not sure that I'd be comfortable combining RSD incidents with the fate of the Mossman Mill. I don't think there's any cause and effect there. But look, it's a question that comes up a lot. And look, there is genetic variation for the microbial titer within varieties in response to RSD infection. So we see some varieties that will have a higher bacterial load than other. One of the lowest that we've seen in terms of the commercial varieties is Q208. Now, if that's as good as it gets, well, Q208 we know gets infected, spreads infection to other plants. You know, it's not particularly useful. You can't just grow Q208 as any form of RSD control. So there are legends and myths about RSD resistant varieties around the world, and we've done our best to hunt down some of those and try and look at them. And as far as we can tell, you know, maybe they're a fraction better than Q208, but we can't find any evidence for a genuine resistance to RSD. So, I mean, I'm all for genetic solutions. You know, they are the best solutions in terms of cost of adoption and scalability. So I'd be all for breeding for RSD resistance if someone could give me a resistant parent to start with, because I haven't been able to find one. So that would be my answer for Anthony.
Thank you, Jason. We got William Bankett that has a question. So William, you can ask your question. You can come on. You can put your camera on too if you want, and your microphone.
Is it okay? I think, am I unmuted now?
Yes, that's good. We can hear you, William.
Okay. Good morning, Jason. Thank you for sharing with us the challenges and achievements of SRA. You mentioned early on your presentation that you have identified a possible energy cane. You have a candidate for an energy cane. What is your definition of energy cane, and how will it be used and accepted by the industry?
Thank you, William, and thank you for being up so late. I know it's 2 o'clock in the morning over there, so thanks for your attention.
Well, up so early, not up so late, up so early.
Okay. Look, it's the beginning, it's baby steps. Obviously, the Australian industry doesn't have a clear path to market or a clear use case or someone out there saying, I want to buy energy cane as a stock for something. But the industry has worked through, I guess, a future-looking roadmap called Sugar Plus, which does, I guess, spell out with some ambition diversification goals for the industry, including alternative end uses. So I don't have a very good definition of an energy cane, William. Essentially, what we have through our introgression program is the sort of range of genetic variation for the traits that you would expect. So there's things in there that are probably 15 to 20% higher yield than our conventionals, but with a significant or proportionate or greater trade-off in terms of reduction in CCS. And at this point, something of an unknown and a bit of a risk around how much is reducing sugar versus how much is sucrose. So it's not so much breeding something to a specification against a known market. It's more beginning to identify agronomically acceptable clones with a range of end-use characteristics in terms of their composition. That's a bit of a waffly answer, William, but that's probably where we're at in terms of the definition of that market segment.
Okay. Any more questions for Jason? I've got a question. So Jason, working from those two different crops, barley to sugarcane, which one is your favorite end product?
I'm not sure I have one. You can have bad beer and you can have a dodgy rum. No, look, the sugarcane industry is fascinating. It is very, very different in terms of the way it's structured and organised, and I guess the codependency of mills and growers is a really unique thing. And I guess the relationships and the natural tensions that come out of that interdependence kind of makes for a unique environment that isn't like any other ag sector, to be honest.
Yeah. So did you ever trying to work on grapes? I know you like wine, don't you?
Well, look, I feel sorry for the poor grapevine breeders because they come up with new varieties, but then the vignerons don't want them because the customer only wants a Shiraz or a Chablis or whatever it is. They don't want some new thing that no one's ever heard of. So I think they've finally capitulated, and the Australian grapevine breeding effort is now moving solely into mutagenesis or gene editing of existing varieties to create just a bit of variation, but not a whole new variety. So that's kind of a sad way to do plant breeding, where you can't invent a whole new thing.
Mm. And so I just wanted to ask you, like, so when you arrived, I remember, like, when you arrived, and we're just talking about molecular marker and how cheap it is for barley, because I did work on barley here with some student, and they have big fat chromosomes and only 14 of them, and it's a diploid. And so did you thought, Ollie, that's a big genome? And I knew you must know what you were coming into, but to the extent of what you expected, or were you very much surprised, in fact?
No, well, sugarcane genetics still hurts my brain. It's not easy. It really, it's not easy. And it's a world apart. I mean, even 10 years ago, we could shotgun sequence an individual variety without having a research project. It was just a $10,000 task. And you compare that to the amount of work that went into the paper you co-authored to put together the first good reference genome sequence. So they're worlds apart in terms of genetic complexity. They're worlds apart in terms of the physical complexity, the execution in the breeding program. So, for wheat and barley breeders, the cost of an average plot is 10 times less than what it costs for an FAT plot. And of course, we've got to run that plot for 3 years. They've only got to run it for 1. So, they've got a lot of advantages, but the bar is also very, very high. There's a lot of demanding traits to select for, and a lot of competitors that you've got to beat if you're going to survive. So there's things about the grains sector in Australia that perhaps are technically easier, but it's a pretty hotly contested space as well.
So do you prefer breeding barley or sugarcane?
No, I've enjoyed both, I think.
Well, that's good. Ashley Eglinton, what feed barley variety would best suit the Riverina area?
I think it's a bit too long since I've been in the industry to be giving variety recommendations about barley, so I think I'm not going to do that. And I know it's a wind up of a question anyway, given the surname, so I'm going to pass.
Actually, I had a question. One of your last slides. Yeah, so if like one grows in the tableland adopt this variety and it's doing like really well and like the profits are better, do you think like this is like the way that the other growers actually will adopt more? Like, or it's like, oh well, maybe we should have just change and
No, I think that variety will move quite quickly. So it's dominated the seed sales on the tableland. Growers are pretty good at seeing what's happening over the fence, and if someone else is doing something that's making money, that's probably worth more than a positive story in a variety guide. To be honest, that on-farm demonstration really does convince people.
Right. Any other questions from yes, of course. Shamsa, go ahead.
Hey, Jason, thanks for the nice presentation. I'm very enjoyed it. Just one thing I'd like to ask. So what you think that your great achievement working in the sugar industry that we can remember you?
Sorry, what achievement?
Yeah, what achievement do you have? You think that it will be, it will impact our sugar industry, sort of?
Not quite sure how to answer that. I think it's the case that there aren't any silver bullets. There aren't any easy, low-hanging fruit. It's all improvements are pretty hard fought and hard won. Whether we're talking about genetic gain and breeding effort or other improvements to farming system or on-farm crop performance. So I'm not really quite sure how to answer, Shamsul.
That's all right. I just
probably just that ongoing effort and commitment from a passionate team. That's going to be the key thing to continued improvement.
I guess another question I want to ask, because of the genetic gain wasn't actually increasing that much we actually hoping for. So what do you think that we should do technology-wise, or maybe what sort of technology you think in future could be used actually making it much better selection and much more better assessment to getting better genetic gain?
Yeah, well, I think we've demonstrated that, Shamsul. I don't think it needs some radical blue sky idea. So we've gone from 0.1% to now the overall program's achieving just over 1% long-term annual genetic gain. If we look at that at a regional level, there's some differences across our regional selection programs. And the very best performed of those is travelling at 2.3% per annum. Okay, so SRA's strategic plan has the aspirational target of achieving 2%. Now, 2% is difficult across the whole program, but we know that it's possible within the current paradigm because one of our large selection programs is already travelling above that. So hard work, no mistakes, kind weather, things not getting in our way, it is achievable.
So do you think the AI in future will reduce the workload for the breeder, plant breeder in selection program or making much more like a better assessment?
No, I think there are definitely places and ways that we can use AI in all sorts of technologies. You know, if you think about it, we do a lot of things that are calibration based already, right? So a CCS value out of Sugarcane is a prediction. So we've been using models to predict things for a long, long time. Not necessarily AI models, and in fact, when we try and use, you know, the ChatGPT model for genomic selection, as our UQ colleagues tried, it doesn't work better than the models that were developed specifically for genomic selection. And similarly, new age models don't operate better than the predictive calibrations used for NIR systems. But I'm sure there are places and ways that we're going to use it. But yeah, for me, I think the active management and the knowledge of context that a breeder has to have in their regular decision making is going to be pretty hard to overtake.
Thanks, Jason.
So Jason, sorry, you got a question from Lily. How do you think the RNAi technology application in the genetic gain? We are working on RNAi delivery. Is there any opportunity to help the gain?
Well, that's an exciting technology, and I think it's almost like a separate, I shouldn't say separate product, but when we talk about genetic gain, I guess we're talking about cumulative genetic progress against a long-term fixed target, like yield, like CCS. I suppose the RNAi targets are really about trying to address some particular barrier, like I'm imagining the one you're working on is to do with pest control. So that actually allows the full exploitation of the genetic potential of the variety with effective control of a pest or disease. If there are ways for RNAi to address our underlying sort of standing traits, I don't know about them, but if you do, Lily, that might be an interesting conversation.
She said plant delivery is possible. And
Awesome.
thanks.
Thank you.
So what do you think that the future in Australia will be for the GM? Are we going to get sugar, like GM sugarcane, or you think like we're going to be ready? And my second question is actually, if we do have GM, for example, then you'll take your top, variety, and then you just, add whatever genes you want or whatever. So then the breeder's job is done?
No, the breeder's job is never done.
Oh, God.
Look, the challenge for GM technology is to come up with a trait or a gene that's going to add enough value, create enough value to offset the deregulation cost and the potential market access issues that it will create. So you kind of have to think of something that's going to be in the mega millions to offset those two things. And I suppose that the challenge when the herbicide resistance was explored, at the end of the day, that trait just wasn't worth enough, didn't create enough value to offset the negatives. So if borers came into the country and we had no chemical control means and we had to go down the GM path, well, then I think that 100% that would have to happen. But in the absence of that, it's difficult to see a trait that's going to create enough value.
Right. Tony is asking which rate sorry, which region is making more gain?
So the region headlining the genetic gain is the northern region at 2.32%.
That's like yours.
It just happens to be where I'm sitting. It's not mine. It's Felicity and Andy and all the people that have contributed to that.
Okay, right on. Cripps, Graham. Hi, Jason. You talk about the cost of testing cane variety because they are a multi-year crop, and because of this, we only take facts to second return. Do you think any of the new technique you discussed have the potential to assess returnability in a quicker, cheaper, and easier way?
It's a great question, Graham. And yeah, I'm really hoping that we're going to put together enough data out of what's happening in the introgression program in the Herbert around these trials that we're harvesting twice a year or that we're slashing to understand whether that really does mimic a much longer evaluation and return crop testing, because it'll be a great shortcut if we can get the equivalent of fourth return data in 2 years. That I think would make a lot of people more comfortable when we say, all right, a new variety like SRA 37's got strong returning as part of its features. If we had that sort of data to back it up, I think that would be good. So answer is we don't have that data put together, but we're approaching a point where we will be able to.
Thanks. All right. Any more questions from anyone? William, do you still have another question? No. Okay. Sorry, it's coming from everybody. Well, thanks again, Jason, for presenting today. And I think we can all agree that was like a really great presentation. Thank you all for your attendance too. I hope you have enjoyed today's webinar and that you will join us at the next SRA webinar coming soon. For information on this webinar, please visit the events page on the SRA website. So thank you and have a good afternoon and a great weekend.
Thank you, Natalie. Thanks, everybody.